Hey guys, it's Vince. Today I want to discuss something in Mach 3 that's called fixtures. And what I've got here is the actual Mach 3 mill manual. And this manual is pretty hard to find. Anybody who purchases Mach 3 in my store naturally gets a hard copy to use for their shop, which I find extremely useful. I'm one of the rare vendors that actually take the time to do that because just logically it makes sense. But one of the big things I think that seems to be a misconception is homing a machine and really machining where you believe the home is. Now, what I want to discuss and why I want to go over this is because I keep getting numerous questions on home switches, limit switches. There's lots of misinformation out there, and I really want to cover logistically what the facts are of those components as far as limit and home switches. Are they necessary? Are they required? And really look into more of what the software you're using is capable of, because the more we know you use the software to its full capability, number one, you're getting a value for it because that's what you're paying for. And number two, when we start incorporating mechanical fixtures or mechanical devices, I'll put it that way, to try to implement precision, you're always going to be limited because you're always going to be limited to the accuracy of that mechanical device. Hopefully that makes sense to most of you. We're dealing with robotics. So the idea of dealing with robotics is we really want to look at this from a standpoint that the machine software is the end-all be-all as far as precision for the machine. Okay, it's how well the end user incorporates that software and understands it and interprets all the settings involved with it that let him actually manipulate it to provide extremely accurate parts. So hopefully that makes total sense, because in all, what you're going to find in your CNC journey is the more you use all of the software you've purchased to start manufacturing, you really are only going to be as strong and as capable as the software you're using and how well you understand it. So right now, I'm in this manual and I'm showing you this right now under, Chapter 7, Coordinate Systems, Tool Table, and Fixtures. Okay, so rather than go through all of this, I am going to put a link to this manual, which you guys can download, and I really encourage you to download and read. And guys, I know this is a lost art. I know reading in the true sense of PDF it seems to be just something that we don't want to do anymore. Unfortunately, I cannot sit here and go over 200 pages of this manual and explain to you all in theory of machining process. But what I can do is put this link up here. And again, the big thing you have to learn when you're using software like this is that you're not really looking to learn every nook and cranny of the software. What you want to do is extrapolate exactly what you require for your projects and master them. And once you master them, you've become a master manufacturer of your componentry. Okay, now if you want to expand upon that, it's totally up to you, and you of course can just continue to disseminate the manual and going through and learning new and different things. Either way, you'll be really astounded as far as the capabilities of the software. But hopefully with this logistical approach, and I'm gonna just cover a couple things with you real quick, not going through theory of just sitting here and reading all this. I don't want to do that. I think that's done online too much. But what I like to do is I found a very interesting video. And what I always do before I make a video is I want to see if there's anybody that's done a video that may have found something or discussed something that they need to just be reiterated on to really drill home the whole point of what the potential of using this option in Mach 3 is. And this individual, his name is Alex Crane. He did a video on CNC tutorial on fixtures and offsets in Mach 3. Well, guys, let me explain to you how limit and home switches work, okay, or the theory behind them. Okay, limit switches are a farce. I've said this in every video. I'm going to continue to say this. Mach 3 has soft limits built into it. You do not need to wire your machine with a mechanical limit switch. It's not necessary to do. That, however, I get questioned on home switches. Well, let's talk about home switches. If you're planning on machining the same project over and over again in the same location, maybe you're cutting out, I did a video on the demo CNC business model. Maybe you're cutting out a RC car chassis or a shock tower, whatever it may be, and you want to cut 100 of those parts out and just load raw material into the same location on the mill and have it start milling at that at that general location and considering that home. A switch is not going to do that. Okay? Let me reiterate. A home switch is not going to put your machine in the ideal machining position for about 95% of your machining operations. Okay? What a home switch does, and this guy is really nice doing this video. I'm going to cover it with you. We're going to watch it together. And again, I fast forward a lot of the small talk. I wanted to get into exactly what he's doing. But we're going to break it down into sections, and hopefully we'll cover it together, and you guys will have a better understanding of what I'm talking about. Because, see, this is where I think there's some misinformation, and I think there's some confusion, especially to my new guys out there, and even guys that have been doing this for years, that maybe they've bought a machine and they've used this machine that they've bought. I hear this all the time. I bought a Chinese machine, or I bought this, or I bought that, and it came with these switches. It's got to be right because it came with the switches. Well, it's got switches. We'll say it that way. Is it right? You be the judge after you watch this, and hopefully this will make a lot more sense to you. Okay, so I'm just going to hit play here and give you guys a little bit of a background. This individual likes to make guitars for profit. He's at a point he's trying to become more efficient in his shop. He decided to do some reading on fixtures and what they can do to him to speed up and make him more efficient because of the concept we just talked about, where you're just loading raw material in and you want to machine the same components out over and over again. And we'll just take it from there. I'll let him explain, and then we can break it down as we go.
How that is going to help me. So, for example, like let's say we have a customer guitar. There's one. Here's a nice rosewood blank, and something like that I'd typically be working with. And the traditional way, or the way I would do this with my old machine, is I'd find a place on the table, and I'd set the blank down. I would make sure that the center line was parallel with the x-axis, of course, and then I'd take my clamps and I'd clamp it down. And I'd make sure it was secure. And then I would hassle with my spindle or my router, and I would jog it until I could align it with my work coordinates and zero it at this point. And as anybody that knows, it's completely necessary that you do that, but it's also very time consuming. And so, so I did this with my old machine. Every time I went to build a guitar, and it drove me bonkers. I hated it. So what I've done is introduce fixturing. And what that is a fixture is a spot on the table that the machine remembers, that will always be consistent, and that you can always put a workpiece in there and go to that same spot, and go to that exact same spot every time with no aligning required. And so what I've done is
Now guys, I just got to stop it there. It's a fixture, and he defines it as going to the table with no alignment required. What he just explained with a piece of raw material where he's manufacturing all the time, and he's looking at basically creating the same pattern all the time. And again, that is what most guys consider homing the machine. Okay? Homing the machine to your work piece, to the piece you're working on, is what more or less, I would say about 95% of my clients discuss. Even if they're new or experienced, they always talk of homing their machine. And the only home that most, I would say again, that's 95% useful is the home relative to your workpiece. Because you want to be able to machine that piece over and over and over again without doing the manual work of setting up that piece every single time, just as he discussed, using clamps, doing everything, taking the measurements, so on and so forth. So I'm going to continue to let him explain this process, and then we'll break it down, because he actually points out some interesting things. And once again, why recreate the wheel if it's already been done? So I'll let you continue to watch the video and we'll cover it together.
Actually etched a line, a center line to my table here, as well as a baseline. Here's the zero mark and the mark that I use for my blanks. Your needs will be different, of course, so you just be creative and make that whatever way you want. But this is how I do mine. And so to understand this now, we need to understand a couple different types of coordinate systems. First is your machine coordinates. Your machine coordinates is your absolute position of where the gantry and the carriage is to the machine. Now, me and mine, my absolute zero is right here. it finds this using proximity sensors. This is an NPN proximity sensor right here, and that'll come over and hit that right there. And same thing with this this pole right here. We'll trip this NPN sensor right here. And in the morning, first thing that I do when I wake up, you know, come in with my coffee, turn the machine on. The machine doesn't know where it's at. Or let's say it's you know, it's moved or got bumped or whatever. It doesn't know where it is. I hit reference all home right there in Mach 3. Now my table moves over, hits the sensor down there. The Y moves over, hits the sensor right there. Now I am above my 0 position up here. This is 0 and exactly 0 every time. Now the machine knows exactly where it is in relation to itself.
Okay, guys, let's discuss some things here. This is interesting. He says now the machine knows exactly where it is in relation to itself, and it's at 0 all the time. First of all, a mechanical switch, I don't care if it's a proximity switch, I don't care if it's a mechanical switch, we have to use logic, and we're talking in machining terms, so precision is everything because you own a CNC. There is no way this machine is going to 0 every single time using a mechanical switch in the exact same location. It will be relatively close, but it will not be perfect. Okay, so first and foremost, keep that in mind. Perfection with machining is relative to the job at hand. Okay, and I can't emphasize that enough. The explanation that he just explained about the machine coordinates and finding a 0 on your table is an arbitrary number, guys. It's totally arbitrary. You knowing where the table is, where your spindle is relative to your table, is arbitrary. I myself, when I manufacture for profit, I want to know where my spindle is in relative to my workpiece because that's where I'm actually homing the equipment to. I am working from my home piece that I'm working on, not from the corner of my table. Doing the reference home position is totally up to the end user, and once again, he is showing you that he's at the corner, the bottom. I guess if you're looking at the table from the rear, you'd be at the bottom left corner. That is not an optimal position to start machining for most operations. Now, you, the end user, it's your machine. I'm doing this video hopefully to educate you and make you see a point of logic. Best practice would reflect that if you were running a router, a mill, or whatever that may be, home position should always be calculated preferably to be towards the center of the table so that your axis position is allowable on both ends to roughly equal amounts. Okay? Once again, if soft limits are set up inside the software, proximity switches and home switches and limit switches and all these other switches are irrelevant because the software will protect the table from any possibility in crashing. Okay, so once again, what we need to define here is what your true objective is when you're homing your equipment. When you're homing, and we speak of homing, there's that miscalculation again of saying, okay, do I know where my machine exactly is relative to the table? Do I know where the spindle is relative to the table? Are you going to be machining in the bottom left corner of the table when you're facing it, looking at it from the rear? Or do you want to have it to where you actually want to speak of the home position where we're actually talking about the material at hand? I'm going to continue the video, and you keep listening because it's very interesting. He stumbled upon this. And you're going to find out that I'm not just explaining it. He stumbled upon it, and you'll see exactly where it's going. Let's continue.
And it's ready to go. See if I go over here. Let's see here. If I go over here and hit machine coordinates. Let's see, where were we? Machine coordinates. 0.
Okay.
We are home.
Okay, he just hit machine coordinates, and he says 0. We're at home. In my eyes, I'm only at home when I'm machining my actual project. That's the home I care about. What he just did is an extra step, and you'll figure it out very shortly. Watch this.
All right, so now, obviously, this is not going to work for me because obviously I need more than just absolute coordinates because if I start my program right here, obviously, I'm only going to cut the half of the door. Well, actually, what it's going to do is it's going to run over and run into a limit switch.
Thank you. Like I said, he figured it out, okay? This is proven not to be of best practice. So therefore, if you are an individual who believes a lot of the hype online about these home switches, limit switches, all this other crap, do your research. Read this. There's a lot of misinformation, and realistically, It's no different. I do graphics as well, whether I'm running graphic projects or I'm running a CNC, I should say a CNC graphic project, whether it be for drafting, graphics, whatever it may be, or I'm running CNC on whatever I'm cutting out, milling, aluminum, steel, carbon fiber, acrylic, whatever it may be. I care about the home position based on my raw material. I do not care about the exact coordinates, an arbitrary number of where my spindle is hovering over the table where there is no raw material and I don't have enough room to optimally machine that piece of raw material. Hopefully this all makes sense. I'm going to let him continue because this is still very interesting.
And the machine will stop, but this is obviously not going to work for me. So I need a way to be able to tell it that, well, this is 0, I'm actually working over there. That is basically what a fixture is, or my understanding of a fixture. Other people might do it differently, but this is how I do it. So I'm going to go over here to my offsets tab, and you can program these in. There's a, I can't remember which menu.
Now guys, fixtures can be all programmed in. I know I'm going to get a lot of messages on that. I still do. I get a lot of them. When I start discussing this, I get a lot of messages. I myself am providing you guys the information. All you have to do is read about it. It's very, very simple to do. Once again, we don't have to recreate the wheel. We have to identify it, bring it to everybody's attention so that they're all on the same page. Again, I'm trying to reflect upon you the best practices to machine. Is this the only way to do it? Absolutely not. I do have some guys that like to use mechanical switches. That's totally up to the end user. I'm once again providing you the optimal process to actually implement to make sure you're going to have the most accuracy and probably the simplest form of machining capability that's offered in Mach 3. So once again, you are getting the most value. We're going to hit play and let them continue.
You go to, but they're easy to program in. G54 is Mach's default. Now G54 I actually leave open, and that's for the one of kind.
As he starts explaining all the fixtures available in Mach 3, there are hundreds of fixtures available in Mach 3. G54 and all the other numbers that you go through, G54, 55, 56, 57, you can add as many as you like that makes you happy with your jobs, okay? Disregard what he's saying about what he did himself. That's what he did himself. If you want to mimic that, that's fine. I do want to say, once again, I'm referring you to the manual that I'm attaching here. Download it, cover it yourself, utilize this video with it, especially in correlation with what I'm discussing, and it'll make sense, and you'll be able to set it up based upon your applications. I'm going to hit play again.
Stuff that I do that I do have to do, like go and find the edges and find your center and all that sort of stuff, like the old process. That one is reserved for that. However, I have two fixtures that I use on my machine. One is G55 and one is G56. G55 is 8 inches in the X direction and 10 inches in the Y direction. And what I mean by that is 8 inches this way, 8 inches that way, and is that point right here. That is G55. When I hit G55, notice right now that I'm going to go back to, if I go over my program run, I'm in machine coordinates right now. If I go to my offsets and I select G55, I go here. All right, machine coordinates are still 0. No matter which fixture I am in, machine coordinates will always be 0. However, I turn off machine coordinates, I go to my work coordinates.
Okay, guys. Point of confusion. Machine coordinates are telling you basically where on the table you are looking at where your spindle is. Okay? That's all it is. When you go to your actual machine coordinates of where you want to go to where your work is, that's where the fixture came up, and that's why it's reflecting -8 and -10 on his X and Y. Okay? So once again, arbitrarily, machine coordinates means basically if you want to know, oh, look, my spindle's hanging, 2 inches off on the X and Y, whatever that means, if that means something to you. Okay? If you're starting a new project, it may be relative. On most projects, especially if you've been machining for quite some time or you are machining for profit, which again, I'm talking to my more advanced guys. If you want to optimize your machining, that's what this individual is doing. I'm telling you now, fixtures are your best friend. If you don't already know about it, even as you're learning, you want to learn about fixtures because they make your life a lot easier. I'm going to now hit play and we'll continue watching the video.
All of a sudden now, we got -8, -10. This is my work coordinates. So here I am, G55. Now I got, you notice I had G55 and G56. I also have G56 over here. Mm-hmm. Now, as you can see, I never use this one. It's there.
Now, guys, actually what he did on this table, and this is the only reason I'm stopping this, is very interesting. He actually engraved in the spoil board where his fixtures are. That's actually a very good idea. A very good idea. The only thing I kind of would disagree with, or would be looking for more precision, because I am who I am and I'm trying to make precise parts as precise as I require them, and again, this is totally up to the end user, I would not just engrave a line in the table. I would facilitate a jig that I could actually place in them lines, in them engraved areas, and make a jig so I can actually put the raw material in the exact same location. If you do that, you are essentially taking out and really removing any variable of tolerance of now working with a limit switch, because again, it's physically there. It's engraved in the spoil board or whatever material you're using to protect the table. Once you do that, once again, his idea of actually engraving in the table is a great idea, but it's still, in my eyes, not totally finished until he jigs up his piece to make sure that he's bolting each piece down in the precise location of the last piece. So if he transfers one piece of raw material, let's say he's doing, MDF, and he's doing a 1/4 inch piece of MDF, and the length and the width are all the same, he wants to make sure that when he changes that piece out, after he's done the first machining process on it, wants to reload another piece, he would insert the jig, place the piece in place. It would then go right to the fixture that's pre-programmed in Mach3, which we'll cover next, and then you would see that the precision of the machine would be even more appreciated, because he's not worrying about direct placement, just going by eye and feel. Here we go. We're going to hit play.
But I rarely use it. I pretty much just stick with G55. So what we're going to do is we're going to hit go to Z. And we are now at 0. And
now guys, you could see he's got a line on his piece of wood. He's got a line, the engraving line in the table, which is a center line. Like I stated earlier, and this now should really make a lot of sense to you, where I was discussing the jigging aspect. If you use some aluminum angle or just aluminum in general, once he does the engraving in the table, he could then insert that, make the width the same width of the engraving in the table, insert that piece of shim, and then he could actually line everything up more or less like a saw fence on a bandsaw, or any saw for that matter. The idea is to keep your pieces perfectly square, keep everything in the exact same location, and all you're doing is basically loading and removing raw material as it's machined. Once again, take note also on the fact that he hit go to Z, and the machine automatically went over there, which is the exact location where he will be machining, which in my terminology I consider to be the true machine home, because that's where I will be machining all of my componentry from. Now, if there are some guys that want to argue that point and say, well, no, that's not your machine home. Well, it's all based, again, on an arbitrary number. Do I care if my spindle is over here where the actual raw material isn't? I mean, on some applications you may care, but you could also set up another fixture to put you on the corner of that table where he considered it to be the absolute 0. Think about it in them terms, because it makes a lot of sense. Here I'm going to hit play and we'll watch it some more.
Machine coordinates now, our work coordinates are at 0, and our machine coordinates are at, basically 8 and 10. Now, that's obviously very...
Once again, he hits the machine coordinate button. It's telling him more or less that he's now 7.9, 9.9 away from where the machine originally hit the actual proximity switches, and that's where he's machining. I'm going to hit play again and let him explain.
It's not exact, but it's very, very close. I mean, if for a machinist, you would actually tune your machine to be more accurate than that, but I'm just a wood router, so I don't worry about that.
Okay.
So.
Once again, we can tell this individual is not really familiar with accuracy, because he actually had it programmed in at 8 by 10. You could see here the machine itself is off by a couple, 10,000ths of an inch we're looking at here, guys. Okay, so he's 2 10,000ths here, 3 10,000ths there. I mean, for wood routing, that's incredible. I mean, that's incredible amount of accuracy, and that's far exceeding any switch's accuracy. So take that into consideration, because what I'm saying here, if you're really looking to learn machining and understand CNC, it's not about a tolerance that might be okay or might be doable. It's about trying to get that work as close to perfect as possible. That's what we're all shooting for. That's the idea of using one of these machines. Now, everybody's outlook is different. Everybody's philosophy is different. I've learned from guys that were machining, 10 thousandths on certain applications was too much. So, I've always tried to shoot for as close to perfect as I could, and I'll be happy with that. Some guys are not like that. Most machinists strive for perfection, and most then are usually considered to be perfectionists. So just keep that in mind as we go on and continue with this video.
For all intents and purposes, my machine coordinates are 8 and 10 at this point.
That's
Let's
right.
say that I wanted to go to my other offset. Let's say I did want to use G56. I can go over here, hit G56, go over to here, program run. Now all of a sudden I hit go to Z.
Now watch, it's going to go over to the G56, which he has engraved. That's a secondary
now
home
all of a sudden
position.
I'm at G56 ready to go. And I'm actually going to go ahead and I'm going to go back to my G55 here because I don't use G56 that often. And let's see here. Go to Z. Alright, so now here I am back at G55. So now every single time whenever I run this, my work coordinates will be at 0. I take my guitar, I bolt it down using the crosshairs, and it is right where I need it every time. No more aligning, no.
Guys, let me reiterate once again. Let's just point of caution. You do not want to just bolt that down and go by eye. Okay? You will, again, I should say this more towards the end user. Again, it's totally your choice. I would use the jigging platform. Like I said, he's already made a center line, and he's also made a crosshash line against that. Once again, if you made a jig, you could use as many offsets as you like. Once again, I think the idea of actually engraving in a table or the spoil board is an ingenious idea if you utilize it to its full extent. The idea, again, and the guys that are really, or I should say the guys that really truly understand machining, they would look at it more towards the term of simplifying the process where they're getting as much accuracy as possible, and that's where that jigging comes in. Just bolting this down and holding it in place is not going to provide the accuracy you're probably looking for or should be looking for. I would do the jig. Once you make the jig, it's very simple to do. Put it in there, you're good to go. If you really want to get crazy too, you could use virtually any material you want, from super flat like glass. You could use 2 small pieces of glass that you get at you can go to the thrift store. A lot of places have scrap glass, super flat. You can go to aluminum, whatever you want. The big thing here is precision. You want to be able to switch out a piece of raw material, pop in the new piece, make sure you're locating it in the exact same position with the minimal amount of tolerance available, and then just hit that fixture. You're going to work right away. Just bolt it down and tighten it down, and you're ready to go. I'm going to continue with the video now.
No more trying to get your gantry and your carriage to line up where you want it. You just press the button and go. Now notice this is only the X and Y. We're not worried about the Z yet. We'll do that in the next video. That is fixtures in a nutshell. That's how I do it. It's not the absolute.
Now guys, when he says I'm going to do the Z in the next video, Z is very simple. Again, depending upon tool changes, once the Z is set, and it's set basically the same way, it's all digital coordinates. So again, the software is just recording the position you are actually setting everything in. Pending this material is the same width, if you're using the same width material, and you leave a couple thousandths variance for using the same tool. If you're doing roughing, of course, you're going to be using the same tool. So therefore, on that project, on that process, you would do all of the same material that you're roughing with, and then change out your end mill. Again, we would have to adjust the machine Z as far as the length of the end mill. You may use a touch plate in order to do that. Once you do that, of course, you'll be all set to go. You can then just reload material, place your jig in location, go to your fixture, and you're ready to rock and roll. Now, once again, you can call it whatever you want. To me, that's my machine home, because that's when I'm producing profit. Okay, I'm not producing profit machining on this corner. Okay, 98% of guys do not want to machine on this corner, because eventually, unless there's a project that's absolutely mandatory, you being on the bottom left corner, the bottom right corner, it's all an arbitrary number. Okay, why people call that their home, okay, it just makes logical sense, is where the limit switches or the home switches are. So when it triggers that, the machine is not going to move anywhere unless you move it, change its origin, and then naturally they would consider that the home. I don't care about my table's measurement in this corner. Once again, I simply care about the home position based on where I'm working from. So once again, keep that in mind on terminology, because again, it's very confusing. There's a lot of terms that are used. Most machinists only care about where they're machining from. They're actually machining a raw material from. There are certain applications, once again, that you would require to know, coordinates based upon where the spindle is located on your table. But again, for how many times you care to know that, if the table's unloaded, it's not making you money. So it's very simple. If there's no material on the table, you're not making money. You're making money when this material is placed on the table, you know you're good to go, and all you're doing is switching the material, hitting the fixture setting. You might be changing and setting the Z-axis as far as any width changes or tool changes that are to be implemented, and other than that, you're ready to go. So hopefully this video has been informative as far as understanding homing better, at least in my terminology, because I think what I'm explaining will make a little more sense than hitting machine coordinates and finding out where, oh look, my machine is home because it's in the corner of the table. Okay. And you'll find out very quickly how many jobs you're going to be able to perform when it's over on the bottom corner of the table, and between your X and Y, whichever side you want to put it on, you're limited in axis movement. Okay, it doesn't make sense, because here's the thing, guys, whether you use a switch or you use soft limits, once again, I don't recommend switches. I always go with soft limits. They never fail. If you're using that method and you're machining from this location, the thing to keep in mind is eventually, maybe not on the first job, but eventually another job, unless you're doing the exact same job every single time, and those are the guys that'll get away with using a switch, you're going to want to move your actual home position. You might home your machine here to say, oh, I'm at 0, if that number means anything, that arbitrary number. Otherwise, you're going to move it to where it's more applicable to what you're actually cutting. So just keep that in mind. Hopefully this has been informative. Once again, if you guys have any questions, my name is Vince. My store is eDealers Direct. I'm on eBay. I'll get back with you as soon as possible, but I think this video is kind of long overdue. I have been getting quite a few questions on it, so hopefully this has been more informative. I'll put a link under the video so you guys can download the user's manual for Mach3, and this is a different user's manual. It's not on Mach3's site, guys. This is more in depth. You can print it out, check it out. Once again, if you order Mach3 from me, I give you a hard copy manual, which again, and you get the discs and all that. A lot of guys don't like the downloads, and you get discs, you get the hardcover, and it's nice to have something to refer back to in the shop, because a lot of times at night when you can't go to sleep or you're just brushing up on some studying, it helps you immensely to have that physical aptitude to go over there, break open the book and say, is this right? Or even in front of the table, is this right? Sometimes it's easier to do that than to go online and try to do research. So I hope it helps everybody. Thank you again. Take care.